All right, today is 8/7, 19. Oh my goodness, I'm off by a year. Okay. All right, graphs of equations. So today we're talking about a couple of things. Did you do now and look at page 19? Yeah? Good. I'll wait till you all open up your books to page 19. All right, so I asked you to find the standard form equation of a circle. So on page 19, what does it say the standard form equation of a circle is?
X minus h
Quantity squared
plus y minus j quantity squared equals r squared.
Good. Now, it's not enough to just understand the form. This is the standard form equation of a circle. You have to know what all the letters represent. So what does the H and the K represent? HK is what?
Center.
Is the center of the circle. Okay? And what does R represent?
Radius.
R is the radius. And so if you have a circle and you know the center and you know the radius, then it's really easy to write an equation. You just have to plug in the H and the K values and the R for the radius, and it's super easy to write an equation of a circle. So this is your last chunk of problems here. They go super fast. All right. Today we are finding intercepts. So we have two goals: finding intercepts and then circles. You do need to know this equation of a circle. You will be tested on it, just so you know. It is something you need to memorize. Okay, so let's talk about intercepts momentarily. So if I have a coordinate plane and then I have here we have a line, a graph of a line. What would this point be called right there? The x-intercept. Very good, the x-intercept. And if you were to maybe approximate an ordered pair for that x-intercept, what might that ordered pair look like?
-3, 0.
-3, 0 or something like that, yeah. So -3 and a 0 for y. That's the key there. We'd have some number in place of the x and a 0 for y. Now, ordered pairs are actually super useful. So ordered pairs actually give us lots of hints. If we want to find an x-intercept, the 0 says set the y value equal to 0. That's what it's telling you to do. So that's how we're going to find an x-intercept. Then, right here, what is this point called? Y-intercept. All right, and again, if you were to approximate an ordered pair for that point, what might it be? 0, 5, 0, 1, 0 something, right? 0 for the x and some value for y. And again, knowing those ordered pairs really gives you lots of clues. It says, hey, take a 0 and plug it in for y, or sorry, not y, for x. Set x equal to 0. And so that's what those ordered pairs mean. They tell you to do stuff. And so we're going to find intercepts by plugging in 0. Must be a problem. The natives are restless.
I skipped 2 and 5.
All right, here we go. All right, here we go. Example 1. Determine the x and y intercepts of the graph of the equation. Verify with a graphing calculator. So again, your graphing calculator is going to prove very useful today. Determine the x and y intercepts of the graph of the equation. So we have quite a few equations today. And the thing we want to start thinking about with equations is being able to look at an equation and have a picture of what it looks like roughly, okay? So hopefully you can do that with these two. I have the equation y equals -2 times the absolute value of x minus 3, and then plus 4. What is the shape of this graph? A V, absolute value V. Very good. Is this an upward V or a downward V? Downward V. And how do we know it's downward? Because of the negative in front. Very good. So these are things that it's really important that you're able to do. And maybe if you can't do it today, that's fine. But that is a goal for the year. It's just when you see an equation that you have an idea of what it looks like in your brain. Okay? So just a rough idea that we know that it's a downward facing V. That's all we need to know because we can learn a lot from that. All right. So we want to find the intercepts. So the easy intercept is always going to be the y-intercept. So how do I find a y-intercept? Set x equal to 0. So we can do that. So I'm going to take my equation and plug in a 0 for x. And then simplify. -2, 0 minus 3 is -3. So we have the absolute value of -3. What is the absolute value of -3? And so then we have -2 times 3 plus 4, which is going to be what? -2. Okay. And so we have an ordered pair. We said that x was 0 and y was -2. Folks, I love seeing things as ordered pairs, mostly because it's something we can check really easily on our graph using our graphing calculators. So intercepts to me should always be ordered pairs because it really is just a point on a graph. So I like seeing them as ordered pairs. Here's the real reason. Y equals 2 is the graph of a horizontal line. Okay? So having just y equals 2 as your answer really actually is kind of incorrect. So a y-intercept is just a point on a graph. All right, we want to find the x-intercept or intercepts. How do we find x-intercepts? Yeah, set y equal to 0. So I'm going to take my equation and plug in a 0 for y. And this is the entire reason we had to do the appendix chapter. The first year I taught this, I didn't teach the appendix chapter, and we came to this problem and nobody knew how to solve it. So this is the whole reason I taught the appendix chapter. How do you solve an absolute value equation? Isolate the absolute value. So good starting point. We need to isolate that absolute value. So what should we do first? Subtract the 4. So -4 equals -2 times the absolute value of x, whoops, minus 3. And then what? Divide by -2. That's really important because we can't have an absolute value equal to a negative result. That would be weird. So 2 equals the absolute value of x minus 3. Now what? 2 equations. Anytime you have an absolute value, you have to have those 2 equations. One where the inside was positive and one where the inside was negative, which you can deal with in lots of different ways. But x minus 3 equals positive 2 or negative. The opposite of the inside equals positive 2. Can, of course, move the negative over to make life a little bit easier. And then if I isolate x, what should I get? 1. Okay. And that's going to be 1 for the x and 0 for the y. So there's one of my intercepts. Over here, if I add 3, that gives me 5. So 5 for the x and 0 for the y. All right, so now we want to graph these. Verify with the graphing calculator. So ladies and gentlemen, get out your calculators. I'm gonna, so on the Casio, you need to go to menu and make sure you're in the graphing menu. Oh, and I'm gonna, oops, exit. Okay, delete my equation. Okay, so on the TI, you guys are gonna go to y equals, and we're going to type in our y equals equation. So -2 absolute value. For the Casio, if you just press option under num is ABS. And you'd want to use parentheses there to denote the x minus 3. So x minus 3 and then plus 4 and hit enter. Over here for the TI, absolute value is under math and then arrow over to num, math, num, and there's ABS. Okay. Now, for both calculators, you'll notice that the equal sign is highlighted. That's really important because the equal sign, if it's not highlighted, it's not going to graph anything. That's sort of the clue that, oh, it's ready to graph. Yeah, so it doesn't like that. Yeah. So we're going to delete that. So you want to use this.
Yeah, that's what
Oh, thanks. Oh, you're in parametric mode. Yeah, let's see. Exit. So, there, have to change that.
Yeah.
Yeah, we'll try and figure it out later. All right. I'm sure there's a way to do it. Okay. Then for the TI people, well, for Casio, you really just have to press draw. That's not a great picture. Let me see if I can do something else. Zoom. Type? I don't know. No. Zoom. Whoops. Nope. Oh, I'll just do draw. We're the TI Zoom 6. No, you don't have to draw the graph. So here's the cool part. For both calculators, the next part works the same. This isn't a great window, and I'm not, B window, what's that? Integer? Oh, okay. Oh, there we go. That's better. Okay. For both of these, the trace button is very cool. All right. So on the TI, we have a trace button, and on the Casio, it's a second function. So if you just do shift and then trace, you see both of them have the cursor pop up. And what we can do whenever we have ordered pairs is it asks for an X value. So my X value is 0. And for both of them, if I just type in a 0 and then hit execute or enter, it's going to spit out the Y value is -2, which is really, really handy. And so you can check all of your ordered pairs that way, just typing in a 1 and hitting enter, and typing in a 5 and hitting enter. And you can see that it verifies all of our ordered pairs that we just found. Okay? And not only that, but you can see them when you graph them. You can see where they're located on the graph. So it's kind of cool. All right. So trace, really useful tool. All right. So hopefully you got that. Let's try another. All right. Again, here we have graph B. What shape is this function? A parabola. We know that because it's x squared. Is it an up parabola or down parabola? Down parabola. It's always important to think about that, just because, even when you go to graph it on your calculator, you make typos, right? And if you saw something like an up parabola, then you'd be like, wait a minute, I knew it was a down parabola. What's wrong? So it's always good to think about that. I want to find the y-intercept. How do I find the y-intercept? Set x equal to 0. So I'm going to do that. Y equals -2 times 0 squared minus 6 times 0. What is that? 0. Okay, really? I didn't need to show all that work because I knew that pretty much instantaneously. So we have 0, 0, which is an x and a y-intercept. It's both. And then I want to find the x-intercepts. How are we going to find x-intercepts? Set y equal to 0. All right, so I have 0 equals -2x squared minus 6x. And then how are we going to solve this? Factor. Very good. This was like that whole worksheet, the extra credit worksheet this weekend. A lot of you did it. And I saw some excellent factoring and solving. It was really, really good. So this has a GCF. What's the GCF? -2x. When you take out -2x, what's left behind? X plus 3. Good. And then how do you solve from there? Set each piece equal to 0. Yeah, we get -2x is equal to 0, which means x is equal to 0. So do I have to write 0, 0, or is once enough? Yeah, we already have that here. I don't need to duplicate it. And over here, if I set x plus 3 equal to 0, we would get x equals -3. So my ordered pair for that would be what? Good, -3, 0. Again, when you take a moment in your calculators, type in the equation and use trace, and x equals what to check. X equals 0, x equals -3, and you should check both ordered pairs. You found it. Okay, good. Where was it?
It's under. It's under.
Awesome. Okay. Good to know.
You
So,
don't need one,
trace. Type in your x values. Type in 0.
The fuck?
I like this one.
Can we do our work, Matt?
All right, let's do one more. That was cute. So anxious. All right. Example 2. Write the standard form equation of a circle. Write the standard form equation of a circle. Write the standard form equation of a circle whose endpoints of a diameter are -4, 1, 2, 7. -4, 1, and 2, 7. You don't have any of this hard in your homework, but I just like this question because it works in everything we've done so far in this chapter. It's an awesome kind of question. So first of all, anytime you have something like this, I have a picture. I'm going to sketch a picture because there's so much meaning behind that picture. So the first thing is I have some points, -4, 1 right there. And then the 0.27, 1, 2, 3, 4, 5, 6, 7. And you can do a rough sketch on your paper. It doesn't have to be beautiful. These endpoints, if I connect them, are what? What are they called? Yeah, this makes up the diameter of a circle, which means there must be a circle that goes through those 2 points. Like that, sort of. That's better. Okay. So those 2 points form the endpoints of a diameter. Tell me more information about a diameter. Half of the diameter is the radius. Okay, what else about the diameter? Goes from one side to the other. So the radius, we can just divide it by 2 to get the radius. It passes through.
The Y.
True.
Circles.
It passes through the center of the circle.
Oh.
It cuts a circle right in half, doesn't it?
In half. Get the center point.
Okay. So first of all, what is the standard form equation of a circle?
X minus 8 squared.
Good. You got to know it, ladies and gentlemen. And so in order to write this equation, we need 2 things. We need to know H and K, which is the center of the circle. And then what else do we need? The radius. All right. And if we know those 2 things, then we can simply plug them in and we're done. That's it. So how do we find the center of this circle? The midpoint. The center is going to equal to the midpoint. Between these 2 points, I'm guessing is about right here. That is going to be the center of the circle. We know how to find the midpoint. How do you find the midpoint?
2 X's.
Add your x's and divide by
2.
2. So negative 4 plus 2 over 2. Add your y's and divide by 2. And so what does our midpoint slash center turn out to be? Negative 1, 4. Very good. Negative 4 plus 2 is negative 2. Over 2 is negative 1. And 1 plus 7 is 8. Over 2 is 4. So we know that we have our center at negative 1, 4. And those are our H and K values that we're going to plug in there. All right, now that we know the center, and that center is right here, a good picture is really worth 1,000 words. So there is our center of the circle. How can I figure out the radius? Distance, the distance between the center point and an endpoint, sure. So does it matter which endpoint I use? No, I'm gonna use this one. Let's choose 7. Yeah, so now distance formula. Hey, we learned that also. Big giant square root. What do we have to do? X2 minus x1 squared. So subtract the x's and square them. 2 minus a negative 1 squared. Subtract the y's and square it. 7 minus 4 squared. 2 minus a negative 1 is really 3. Squared is 9. 7 minus 4 is 3. Squared is 9. So we get radical 18. And how does that simplify? 3 radical 2. Good. It's 9 times 2. The square root of 9 is 3. Radical 2. Okay, so we found our radius, 3 radical 2. And all I have to do to write my equation is plug those things in and clean it up. So I have x minus a negative 1. So what should I do? X plus 1, quantity squared. And then we have y minus the k value, which is 4, quantity squared, equals our radius was 3 radical 2 being squared. I want to clean up that radius. What is 3 radical 2 squared? Almost.
Oh.
It would just be 18. Yes.
Oh, yeah.
Okay.
That's how
First of all, it was right here, right? There's radical 18. And if you square it, that'd be 18. Why is this? 3 radical 2 times 3 radical 2 would be, what's 3 times 3? 9. What's radical 2 times radical 2? 2. There's the 18. Okay? This is our equation of the circle. Alrighty. you have any questions for me? All right. You can get started.